we begin. Yep. That got on YouTube. Okay, so on Wednesday the 20th, that's today, we're doing complex numbers or complex zeros. And what does that mean? Well, that means this. Here's a question, all right? Let's see if you can figure this out. You should be able to do this. I'm thinking of a polynomial of degree 5, okay? With how many roots? 5 roots. But I'm only going to tell you 3 of them.
I hate you.
Degree 5, okay? Yeah. All right, so I have a degree 5 polynomial, right? And there should be, therefore, 5 roots. But I'm hiding these. Why? Because you can tell me right away what they are. Can't you? It's over there. This is 1. This is 5i. This is 1 plus i. All right, let's focus on this. If 1 plus i is one of the roots, don't you know another one automatically?
Yeah, 1 minus i.
1 minus i, because they come in complex conjugate pairs.
And negative 5i.
And is negative 5i a complex conjugate? Yeah, because it's 0 plus 5i, really. So when you do the conjugate, you get 0 minus 5i, right? And isn't that the same thing as negative 5i? Okay, great. So the first question is, can't you figure out missing roots? If you know one complex number, you know the other one, right?
Yeah.
That's easy? That's easy, right? Okay, okay, here's the fun part. Are you ready? All right, this is like Jeopardy. You know in Jeopardy, the answer is the question. This is my question. What was the equation I solved? What was like the original problem? Can you figure out a polynomial whose roots are those 5 roots? Well, let's start you off. If one of the roots is 1, one of the factors had to be x minus 1, right? Do the same thing for all of these. If one of the roots is 5i, one of the factors is x minus 5i. Let me do this one. If this is a factor, what's the root? Sorry, if this is the root, what's the factor? X plus 5i. Oh, you're so good at this. I thought this was tough. Oh, gosh. All right, now let's do this one. If this is a root, what's the factor? X minus the root. Now notice, this is more complicated. This is one term, this isn't. When you subtract, you add the opposite. I better put parentheses to know what I'm changing signs on, right? All right, and what's the last factor then?
X plus parentheses.
No, it's always x minus the root. There you go. So that's the equation that I solved to get these numbers. But what was the original equation all foiled out? Can you foil that all out? All right, let's do it. Oh, we're good at this. Are you ready? Okay, how about we start here? How do you multiply? You don't need how. We'll check with how. How about that? But you don't need how. This isn't that tough. Remember, when you multiply complex conjugates, you always get the sum of 2 squares. What's the number? What's this squared? X squared. What's 5 squared? Just the coefficient. 25. I'm telling you, this is x squared plus 25. If you don't believe it, foil it out. First terms, multiply it out by 4. What do you get? X squared. Outer terms, plus 5i, okay. Plus 5ix, okay. Inner terms, minus 5ix, okay. And last terms, negative 25 I squared. What happens to these guys? They cancel. What is I squared really?
Plus 25.
So this is positive, right? This is negative 1, so that's positive. So don't I get x squared plus 25 like I said?
Yes.
Remember, to factor the sum of 2 squares, you use complex conjugates. When they said last year that you can't factor the sum of 2 squares, they lie.
Liars!
Do you know? They always lie. No? You okay? Okay. How about we foil out these 2 guys? Okay. Well, wait. You know, well, not yet. Hang on. I'm just going to copy over what we got. Okay. So this simplifies, right? So let's write it all simplified like. This is x minus 1. This is x squared plus 25. moving. All right, so let's FOIL these two now. X times x. First terms gives you? Anyone know how to do FOIL?
X squared.
X squared. Okay. Outer terms?
X.
That's 1 minus I there. Well, it's x times this. So how about negative 1 minus I times x? We'll distribute later. We'll distribute it later. Inner terms? Because it's negative. What about inner terms here? So negative what?
1 plus I x.
There you go, perfect. And then last, well, a negative times a negative is positive. And when you multiply complex conjugates, you get the sum of the squares of the coefficients. 1 squared plus 1 squared is 2. If you don't believe, do it on the side here. Oh, you believe, I guess. Now let's FOIL this. If multiplying this times this is another FOIL, right? I'm just doing this times this. It's a lot of foiling. Your favorite F word, I know. So, it's 4 letters. Yeah, I know. Okay, so what do you get? First terms? 1. Outer terms?
1I.
Well, be careful. Negative I, right. Inner terms?
Plus I.
Positive I, right. And last?
S.
Negative I squared.
You better.
Yep, I hope so. And a negative I squared is? Really 1. And what happens to these guys? So you get 1 plus 1 is? 2. See, I told you. Yes, you rang?
Yes.
What?
Am I doing these wrong?
Huh?
Am I doing them wrong?
That looks pretty good.
Wait.
Yeah,
hold
no,
on,
that's
hold
good.
on. No,
You're
wait.
good, you're
Can
good, you're
Wait, stop. Wait.
No, I won't stop. What?
Okay. This. Hold on. I'll be back.
All right, do the same thing. It's good. You're doing good. All right, so this is simplified. This is simplified. What about this? Ugh. Well, let's see. What if we distribute negative x times this stuff? That might be easy to do, right? All right, so let's see. I'm going to copy this over. I'm going to copy this over, one step at a time. All right, and then it's x squared. So negative x times 1 is negative x. Negative x times negative I is positive ix. Because I have a negative 1 and an x multiplying this. So I'll put them together and distribute. Distribute the negative 1 if you want. Subtracting is adding the opposite, right? So you change the signs and distribute to the x. How about that? Same thing, right? All right, do it here. Negative x times 1 is negative x. Negative x times I is negative ix. And you got this plus 2 still hanging out. Now what happens with the x's? They combine to what? Negative 2x. What about the ix's?
Well, they cancel out.
They cancel out. They combine to 0. Okay. So you got x minus 1, x squared plus 2x, 25, and x squared minus 2x plus 2. All right, you're almost there. Because the question was, what was the original problem before they started factoring? This is still sort of factored. Can't you FOIL this out some more? Oh boy, it's so much FOIL, so little time. You don't like it, I'm so sorry. Okay. You know, I got an email on my YouTube last night from some guy in Algeria. And he's like, I am enjoying your videos very much, but your rentals, you got to make them available in Algeria. Apparently, rentals. Have you noticed? After we finish a chapter, if I start like chapter 4, the previous chapter, I changed them all to rentals on YouTube. And the guy can't see the rentals because the rentals are only available in the USA. And he's like, do me a favor, please change the rental thing. And I can't. They don't have that option. They only allow rentals in the USA. Huh? Maybe. Okay. By the way, don't forget, you have access to the videos for free on my FTP site, which is top secret. Don't tell nobody. Well, then I'll just take it down. I'm giving it to you for free, you know. Oh God, it was some crazy name, I forget. Well, it was his crazy YouTube. Then he'll smile.
Oh, he mentioned me.
Huh? Yep. Okay, So let's do some more foiling. Aren't you happy you know how to foil? Okay, first terms. Let's do these guys. What do you got?
I did.
What do you got? Nobody knows? X cubed, okay. Outer terms.
25x.
Plus 25x, okay.
X squared.
Inner term.
X squared.
Careful. Negative. And last,
Negative 25.
negative 25, okay. Times this stuff. But usually, after you foil, there's like terms to combine, are there?
No, there are.
Not this time, but it's not in standard form. What don't I like about this? Yeah, now that's not really a big issue when you're foiling out. It's a big issue if you're factoring. It's easier if it's a standard form, but might as well be standard, I guess. Okay. Now, what's left to do? This is all one freaking problem. One freaking fracking problem. That's a well, actually, good question, but be careful. It's a trinomial and not a trinomial. What is that? Quadrinomial. Yeah, that's even worse. Quadrinomial. So, quintinomial. Sextinomial. Yeah, Dylan's an expert on sextinomials.
Yeah, right.
Okay. So, see, that's why the guy in Algeria is enjoying the YouTube. Okay. I am enjoying our YouTube so much. This is what he wrote. You can tell the accent by the way they spell. Well, no, by the grammar, by the way they put the words around weird. Yeah. So anyway, I am enjoying so much your YouTubes. Okay. Something like that, yeah. Okay, but we digress. All right, now notice this is not FOIL anymore. Okay, we're not in Kansas anymore. Okay, FOIL is a binomial times a binomial, right? But remember what FOIL is. It's shorthand for forget this and distribute x. Forget this and distribute the negative 1. Do the same thing here. Forget them, distribute x squared. Forget them, distribute the negative 2x. Forget them, distribute the 2. Yeah. So instead of 4 terms, you're going to get 12. Aren't you going to get 12 products? Right? 2 divided by 2 will be 4 products. 3 by 4 will be 12 products. No, there's a point to this. Hang on. Shh. Yeah, we got to do that. What? Look, man up. We can do it. Huh? Yeah, the question is, what's the original problem before they factored anything? Yeah, it can't be in factored form. All right, now, it's up to you. Do you want to FOIL this way? Like x cubed times everything? Or the other way? You can do either way. I'm going to go this way. I feel like doing it this way. All right, so x squared times x cubed, x to the 5th. X squared times negative x squared, negative x to the 4th. X squared times 25x. 25x cubed? Yep. X squared times negative 25? Negative 25x squared. Good. Okay. Wait, I need some more room. Okay, let's take negative 2 and distribute. Negative 2x times x cubed. Negative 2x to the 4th, right. And negative 2, I'm lining up like terms because I'm going to combine them later anyway, right? Make it easy. Negative 2x times negative x squared? Positive 2x cubed? Okay, go ahead. Negative 2x times, what is it, negative 25x? Negative 50x squared? Negative 2x times negative 25? Positive 50x, right? Because a negative times a negative. Okay, now by 2, that's easy, right? 2x cubed minus 2x squared plus 50x minus 50. Okay, good. Let's combine all the like terms, and then we get a new equation equal to 0, and it's done. Hey, all right, this combines with nothing, right? So what do you write? X to the 5th. These combine to what? 3 x to the 4th, right? When you combine like terms, you don't touch the exponents, you just add the coefficients, right? All right, how many x cubes do you get?
27.
Not quite. 25 plus 2 plus 2. Plus 29? Okay. How many x squareds? Now, careful. Negative 25 and negative 50 is negative 75 and negative 2? Negative 77. Combine these. 100x. And this one's really tough to combine, right? There you go. All right, there's the answer. Because the answer is, what was the question? But, yeah, well, such is life. Now, how do you check that? How do you know that's right? You could have made like 50 million mistakes and those coefficients could be all wrong. We can check with how, but can you check some of this on Ziggy? Look, remember that one of these roots was real. So if you graph, if you graph this, you're going to see it hit the x-axis how many times? If you graph this, how many times does it hit the x-axis? No, look at it. How many real roots do you see? 1. When you hit the x-axis, you're only getting real numbers. Right? So Ziggy can't give you these. But Ziggy can get you this. Let's see that not only do we get a polynomial that has one x-intercept, it's in fact x equals 1. Okay? So let's call out upon Ziggy's powers. Come on, Ziggy. I'm going to make this a little smaller. Okay, Ziggy, get to work. Let's go to y equals. Oh, guess what? It's right there. Amazing. How did that happen?
No, you cannot.
It's so magical. That would be a good thing, I guess. Okay. I don't know why there's an extra space there, but all right. Okay, is that what we got? This is what first period got. Is that what we got? X to the 5th minus 3x to the 4th plus 29x cubed minus 77x squared plus 100x minus 50. Sounds good. All right, how about a zoom 4? Remember, you should only see that go through x equals 1, do you? That's x equals 1 right there. If you trace it to 1, ding, 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 ding. Hal can do everything. Yeah, I'm going to do that right now. Okay, whoops, what happened? Okay, so notice when x is 1, you get exactly y equals 0. That is a real 0. But what about the complex zeros? Isn't that what this unit is about? 4.3? We're in 4.3, and your homework tonight is the multiples of 5 on page 266, 267. It's about the complex roots. How are you going to get them? Yes?
Do I have to like work out each one, or like if I give you like just the like? Can you stop talking?
Yeah, list them out.
Do I do I have to show the work for each one?
That's not the work. The work is that fraction thing. We write you write the factors of the last coefficient divided by the factors of the first coefficient. That's what you write.
So can I just write this?
That's good.
For each one?
Yeah.
For the rest?
Okay.
Like if I just give you the answer?
Yeah, that's fine. Yeah. Yeah? Okay. All right, so no talking behind people's backs. You're on YouTube. We have evidence. Okay. All right, now, you want to see this on Hal? Fine.
Yes.
Let's take out Hal.
Oh, God.
Come on, Hal. In fact, you know what? We're going to make it even better. Colossus.
Is he bigger than Hal?
Yes. Here's Colossus. Now, Colossus is just like Hal. It just has a QWERTY keyboard, so it's easier to type, and it has a bigger screen. That's all, more resolution. All right? It's just like it is. This does exactly the same thing that Hal does. Okay? Does the exact same thing that this guy does, except the keyboard isn't, foobar. All right? All right, so let's bring it out. Whoops, wait. You stupid. It's too big. I can't wait. Hang on. Bring this down a little bit. Okay, this is Colossus. All right. Yeah, have you ever seen Colossus in the flesh? Okay, yeah, we got to get Colossus. Wait. I'm still talking on YouTube. It's okay. Hang on. All right, where's Colossus? Come on, Colossus. Where is Colossus? Colossus is right here. Hello. All right, we got Colossus. Here it is. Huh? Yeah, right here. I was still talking on YouTube. You didn't hear me though. Yeah. Now, by the way, this school is too cheap to get AA batteries. Everything's AAA for the TID3s, right? So it doesn't work because I took the AA's out, but there it is. Okay, if you put in AA's, it'll work. Okay. So, well, that one, they don't make that one anymore. They replace it with the TI Voyage, which does the same thing. Excuse me, if you're going to be fooling around with my Colossus like that, I'm going to take it back. Okay, so let's figure out what Colossus says about this answer. Okay, this was the answer we got, right? Okay, there it is. I'm going to type that into Colossus, and I'm going to ask Colossus to solve it for us. Okay, here we go. So first you got to turn him on. There he is. And wait, clear. Let me just start from scratch. Okay. Okay, you ready? So you do this. Notice that Colossus is a computer algebra system. It does everything algebraically, unlike the TI-83, 84, which does everything numerically. Okay? This can also do it numerically. But if you go to F2, notice the trusty solve key. And what are we solving? Well, here it is. X to the 5th. Okay? Minus 3x to the 4th. Okay? Plus, where's 29? 29x cubed? All right. X cubed. And then minus 77x squared. Plus 100x minus 50. Too much. Now, this calculator doesn't exist anymore. They don't make it anymore. They replace it with the TI Voyage, which is about 200 to 250, somewhere there. All right. Now, okay. Now, the syntax for the solve command is I have to write the equation, equals 0, and I got to say what I'm solving for, comma, x. Okay? There you go. And it's busy, and he's busy, and he's busy, and he's working real hard. And come on, Colossus. Colossus, today would be good. And he's busy. Hello? Are you doing something? All of that, and I get the real root again? What? Oh, well, I was kidding. Look, solve only gives you real roots. C-solve gives you complex roots. Sorry. All right, I'm busy looking for all 5 roots. Come on, Colossus, you can do it. There they are, look at them. Weren't they? 1 plus I, 1 minus I, 5I, negative 5I, and 1. Aren't those the roots we started off with? Look. 5I, negative 5I, 1 plus I, 1 minus I, and 1. They were the exact same numbers, yes? There they are. All righty. But there's more than one way to skin a cat, as you know. Well, I'll try it sometime. If you try it, you'll see. There's more than one way to do it. Okay. Wait. Okay. Now, the thing is this. We're actually moving away from graphing calculators. Graphing calculator technology is over 20 years old, and it's starting to feel its age. I'm using this thing lately. It's a supercomputer set up at Clemson University called SAGE. SAGE stands for Software for Algebraic and Geometric Experimentation. It runs on a supercomputer for free. Anyone can do this. Let me show you how you do this on SAGE. Okay, here we go. All right, SAGE, I have to make a little worksheet. Let's call it 4R period 9. This is beyond anything you could dream. This is beyond Colossus. Okay? All right. Let's do the same thing we just did. Are you ready? I'm going to do solve. Okay, now let's do that equation again. Let's see. Oh, here we go. X to the 5th. Okay. Minus 3. Now, I have to write a multiplication explicitly in this system. It doesn't understand 3x x to the 4th if you don't write the time symbol. Okay? So there you go. So 3x to the 4th is like that, plus 29 times x to the 3rd. Okay? And then minus 77 times x squared. Okay? And then minus 100x. Okay? Minus 100 times x minus 50 equals 0. Yeah, I know. Now, the system is a little bit weird. Equals equals is a Boolean operator. The question is, when is this true? A Boolean operator is something that's either true or false. Okay? We're asking, when is this equal to this a true statement? That's what we're asking. This is a different statement. That makes it equal to 0. We don't want that. We want to see what values of x make it 0. And then I have to say I'm solving for x. And, whoops. And let's see what... Yeah, it's on the website, sagemath.org. It says everything. Okay, and... Uh-oh, what did I do? Wait, hang on. Did I type this wrong? Yeah, you have to say come x, right? Wait, did I type it wrong? Wait, hang on. X to the 5th minus 3x to the 4th, right? Plus 29x cubed minus 77x squared plus, aha. There you go. Okay. I typed it in wrong. I had a minus here or something, right? Okay, look, are these the same roots? The real root was x equals 1.
I'm supposed to go to the next.
Okay. All right, so the real root was 1, remember, from Ziggy? And there was also a negative 5i and a positive 5i. There they are. There was also a 1 plus I and a 1 minus I. There you go. Perfect. Okay. What about graphing it? Well, graphing it is still only going to give you the real roots, right? Let's see what that's about. If I graph this,
Is this how long it's going to take for 1.5?
I'm just showing you the same problem in different ways.
And then we have to go on the computer. All right, let's go.
Now look,
Oh my.
is that what you expected the graph to look like?
Yes.
Well, yes and no. It's not complete, but doesn't it have a 0 at x equals 1? Right? It looks like it. If that's not obvious, I can change the domain. It's only graphing from negative 1 to 1. What if I tell it to graph from negative 2 to 2? Now you see that is a 0, right? It's going up to x equals 1, and it's going past x equals 1, y equals 0 right there. Okay? What if you wanted to graph this for more values? How about from negative 10 to 10? Now it's not obvious what the 0 is, but then you see the end behavior. What is this number? This, what do you think that is? 5 times e to the 4th, yeah, but you know what it is? It's not really e. That means scientific notation. So 5 times 10 to the 4th, 50,000, right? Isn't that 50,000? All right, so this is going way above 50,000 and way below negative 15,000, negative 15,000? Well, more than that, negative 150,000, right? Okay, well now wait. Can this thing factor?
I bet it can.
Can it factor this mess for us?
Yeah.
Let's see. Factor.
Are you serious? I didn't do this type.
Oh yeah, there you go. Well, that's not factored the way we had it, because look what we had. We started with all of this mess. But didn't we get something like that somewhere along the line? That's completely factored without regard to I. If you want to factor this in your head without I, that's what you would get. Isn't that what Sage gave us?
Wait, if you write anything in it, it'll do it? Like factor, like divide?
If it can be factored, yeah.
Like,
Right, this calculates stuff, even numerically, very fast. What if I wanted, look, what if I wanted to figure out 2 to the 7th? Okay. What about 2 to the 77? Okay. How about 2 to the 777? What would you have to do to get that by hand? Multiply 2 by itself 777 times. After 500 sheets of paper, you'd probably get it wrong. Okay. Well, you probably put your foot in your mouth 1,000,000 times. Well, this is one number. That's 2 to the 7,777th power. Yeah, trillion is only like about here. Or maybe here. Okay? Yeah. Well, I could find out how many digits that is. It's 2,300 digits. You want to memorize pi?
Yes. 3.145.
digits of pi. This is not stored in the computer. This is calculated by some formula. You want 1,000 digits of pi? Okay, memorize that for homework. There you go. There you are. Huh? Really? It is huge. It's almost like a little laptop. The batteries are dead. I gotta get new batteries. They're double A's. Yeah. All right. So anyway, I think we're going to get away from graphing calculators, and we're going to end up using computers in math class real soon, all day, every day. For pi, there's actually a formula that allows you to calculate every single digit of pi exactly. So I just asked it for 1,000 of them, and it calculated it on the fly. Yep. How about 100,000 of them?
Wait, did you plug in our grades?
I think I did, yeah. Yeah, all right, hang on. Let me just save.
Garcia, did you update the grades?
Yeah, I think I did. Whoops, wrong one.
I need to get to my bus.
Yeah, but I have to,
Can you say this later or not?
no, I gotta get this done. Because I can't stay here forever. All right.
How long is this going to take to get it?
It shouldn't take too long.
Well, I guess my bus.
I don't know. If you gotta go to a bus, go. I gotta get to this.
Oh, that's tomorrow.
Okay.
I know I got like the